Imagine being slammed by 1500 degrees Celsius. That's hotter than molten lava, while screaming through Earth's atmosphere at 28,000 kilometers per hour and surviving it. Now imagine not just surviving, but doing it again and again. This is the story of Starship's Nose Cone, a metallic marvel that doesn't just endure re-entry fire, it re-flies. But how does SpaceX pull off something that even NASA's Space Shuttle couldn't? Stick around, because by the end of this video, you'll understand why the nose cone is one of the hardest parts of Starship, the secrets behind its heat shield tiles, and the crazy engineering that makes it reusable. And if you're new here, hit that subscribe button and turn on notifications, because what we're about to dive into is going to melt your brain faster than a plasma stream at Mach 25. When you look at Starship, that shiny stainless steel bullet soaring toward orbit, your eyes instantly go to the nose cone. It's sleek, pointed, almost elegant. But it's also one of the most stressed parts of the entire vehicle. During re-entry, the nose cone is the first to meet the atmosphere. Every molecule of air gets violently compressed right in front of it, creating a bow shock, a thin region of plasma hotter than most furnaces on Earth. At that moment, the air isn't really air anymore. It's a superheated soup of ions, and it bombards the nose cone with temperatures around 1500 degrees Celsius, sometimes peaking even higher depending on entry angle. This means the tip of Starship's nose cone experiences extreme heat, violent pressure loads, and dynamic structural vibrations. And yet, when Starship finally lands, that same nose cone is expected to survive, be inspected, and then fly again. No vehicle in history has had to do that this way. Let's rewind a bit. SpaceX's goal isn't just to reach orbit, it's to make spaceflight fully reusable. Falcon 9, sure, it lands, but it's half the story. Starship aims to be 100% reusable, from the massive booster to the delicate tip of the nose cone.
But there's a problem. Traditional spacecraft use ablative heat shields, materials that literally burn away to carry heat off the surface. That's great for one-time missions like Apollo or Crew Dragon, but terrible for reusability. Starship can't afford that. So SpaceX took a radically different approach: ceramic heat shield tiles directly attached to the stainless steel body. And here's where it gets wild. The nose cone not only holds these tiles, but also serves as the aerodynamic anchor for the entire upper stage. It must balance thermal protection, aerodynamics, and structural strength all in one piece of stainless steel. So how do you design a metal shell that can laugh in the face of 1500 degrees Celsius and still be ready for the next flight? If you've ever wondered why Starship is silver instead of white, the answer lies in one of Elon Musk's favorite materials, stainless steel, specifically 301 stainless steel. Unlike aluminum, which melts around 660 degrees Celsius, or carbon composites, which lose strength at high temperatures, 301 stainless steel stays solid and structurally strong up to 1500 degrees Celsius, right around Starship's peak re-entry heating. It's cheap, it's strong, it's ductile, and it actually gets stronger at cryogenic temperatures, which is perfect because Starship's tanks store super cold liquid methane and oxygen.
When SpaceX switched to stainless steel, everyone thought Elon had lost it. But in reality, it was a brilliant thermal trade-off. You see, the shuttle used fragile silica tiles that were effective but brittle and time-consuming to replace. SpaceX instead went for a structure that could handle more heat naturally, reducing the number of tiles needed, especially near the nose cone. So instead of the whole vehicle being heat shielded, only the belly and nose cone face the full fury of re-entry. Now let's talk about the real stars of the show, those black hexagonal tiles that make Starship look like something out of science fiction. Each tile can withstand over 1400 degrees Celsius, and they're designed to expand and contract independently without cracking the steel beneath. Unlike the shuttle's square tiles, Starship uses hexagons, and that's not just for looks. Hexagons eliminate straight-line failure paths. If one tile gets damaged, heat can't easily spread to its neighbors. The tiles near the nose cone and leading edges are slightly different. They're made from a denser, high-temperature variant, capable of taking on the most violent re-entry heating.
And to prevent them from popping off, a problem seen during early Starship tests, SpaceX uses special mechanical clips that let the tiles float slightly as the metal beneath expands. Remember SN-15? That was the first Starship to land successfully with tiles still attached. That milestone proved the concept. Ceramic protection on stainless steel works.
But surviving heat isn't enough. Starship also has to control its fall. The nose cone plays a massive role in that. During reentry, Starship doesn't come in nose first like a traditional rocket. It performs a belly flop maneuver, presenting its flat side to the air to maximize drag and slow down without burning extra fuel. But here's the catch. Even though it's belly flopping, the nose cone still leads the airflow pattern. Think of it as the pivot point for the entire vehicle's aerodynamics. Tiny shifts in its angle can drastically change where the shockwave forms and how much heat reaches the tiles. To manage that, SpaceX designed internal structures inside the nose cone that are incredibly stiff yet lightweight, forming a skeleton of rings and bulkheads. These not only hold the tiles, but also anchor the forward flaps, which act like giant air brakes to stabilize Starship during descent. So the next time you see Starship gracefully falling sideways, remember, it's the nose cone and those flaps doing most of the hard work. At SpaceX's Starbase in Boca Chica, Texas, the nose cones are practically works of art.
Each one is assembled from rolled stainless steel sheets, welded into circular rings, and then stacked vertically. After welding, the seams are polished and inspected for microcracks using ultrasonic sensors. Once the structure is complete, internal stiffeners, mounting points for the payload bay, and heat shield interfaces are added. Then comes the fun part, tile installation. Each ceramic hexagon is carefully positioned using laser mapping to ensure perfect fit and spacing. Even a small misalignment can create a hotspot, and at 1500 degrees Celsius, a hotspot can mean catastrophic failure. SpaceX has gone through dozens of nose cone iterations, improving the sealants, clips, and even the geometry of the tiles themselves. One major breakthrough came with Ship 24, where new insulation techniques behind the tiles significantly reduced heat transfer to the steel. It's all part of SpaceX's brutal test philosophy. Build fast, test hard, learn faster. When Starship hits the atmosphere, the nose cone becomes a glowing torch. A thin plasma sheath forms in front of it. That's the superheated air molecules stripped of electrons. At this stage, temperatures spike over 1400 to 1500 degrees Celsius, and the surface glows cherry red.
Infrared cameras during test flights showed just how intense that is. But the amazing part? Once Starship lands, the same nose cone, the one that just endured that hellfire, is reusable. Engineers have inspected post-flight vehicles and found minimal deformation in tiles that can be reused with minor touch-ups. That's a massive step forward. NASA's shuttle used to take months between flights just to replace cracked tiles. SpaceX is aiming for refly within days. And that's the payoff. A spacecraft that doesn't just survive reentry, but embraces it as part of its reusable design. So what's actually inside that gleaming tip? The upper portion of the nose cone houses avionics, pressurization systems, and sometimes Starlink payload adapters. In the future, for lunar missions, this section will transform into payload bays, crew cabins, or even propellant transfer interfaces. That means SpaceX isn't just protecting a hollow shell, it's protecting mission-critical systems. The engineering here is insane. Every wire, sensor, and structural beam must survive violent vibration, scorching plasma, and freezing cold, all in one flight. We're still in the early days of Starship's evolution.
Each new test flight pushes the limits, and every successful re-entry proves the design further. The nose cone that reflies isn't just a cool engineering trick. It's the key to making human space travel sustainable. If SpaceX can perfect this system, we're looking at a world where rockets can be turned around like airplanes, refueled, inspected, and ready to go again within hours. Imagine flying to orbit, landing, refueling, and heading to the moon, all with the same vehicle. That's the vision, and the nose cone is literally the tip of that dream. But here's the twist. SpaceX isn't stopping here. Elon Musk has hinted at actively cooled tiles, advanced heat exchangers, and even liquid methane channels running beneath the nose cone surface, technology that could make Starship survive multiple orbital reentries with no tile replacement at all. Can a spacecraft one day endure 10, 20, or 50 re-entries without repair? That's what SpaceX is testing right now, and the results could redefine how we access space forever. So next time you see Starship on the pad, glinting in the Texas sun, remember, beneath that shining steel is a nose cone that stares down the fury of atmospheric re-entry and dares to do it again. If you found this deep dive as fascinating as I did, hit like, drop a comment with what part of Starship you want me to cover next, and don't forget to subscribe for more deep space engineering explained like never before. Because here, we don't just watch rockets, we understand what makes them reusable. Until next time, fly safe, stay curious, and keep looking up.